HD 189733b, located 63 light-years from Earth orbiting a star in the constellation Vulpecula, HD 189733b was discovered in 2005 through transit photometry. This cobalt blue gas giant completes one orbit every 2.2 Earth days at a distance closer to its star than Mercury is to our Sun. Surface temperatures reach 1,700 degrees Fahrenheit on the day side, while the night side experiences only marginally cooler conditions. The atmosphere contains silicate particles that scatter blue light, creating its deceptive azure appearance. But HD 189733b's most terrifying feature is its wind. Atmospheric models indicate sustained wind speeds exceeding 5,400 miles per hour, 7 times the speed of sound, carrying those silicate particles horizontally across the planet. These microscopic glass shards create sideways rain that would shred any object in seconds, turning the beautiful blue world into a cosmic sandblaster. HD 189733b demonstrates that beauty and lethality are not mutually exclusive in the universe. Next, we have WASP-12b, discovered in 2008, approximately 1,400 light-years distant in the constellation Auriga. WASP-12b orbits so close to its parent star that one complete revolution takes only 1.1 Earth days. This proximity creates gravitational stresses that deform the planet into an egg shape rather than a sphere. Surface temperatures exceed 4,000 degrees Fahrenheit, or you're hot enough to vaporize most metals and break apart water molecules into constituent hydrogen and oxygen. The parent star's gravity literally tears atmospheric material away from WASP-12b at a rate of 6 billion tons per second, creating a stream of planetary matter spiraling into the star. Astronomers calculate WASP-12b has only 10 million years remaining before complete stellar consumption. The planet's carbon-rich atmosphere may contain clouds of powdered graphite and even hydrocarbon soot. WASP-12b represents a planet in its death spiral, a world being actively devoured by its own sun in astronomical real time. Next up, Kepler-78b, situated 400 light-years away in the constellation Cygnus. Then Kepler-78b was identified in 2013 as one of the first Earth-sized exoplanets discovered. This terrestrial world measures only 1.2 times Earth's diameter and 1.7 times our planet's mass. However, Kepler-78b orbits its star at a distance of less than 1 million miles, completing each orbit in just 8.5 hours. This extreme proximity results in a dayside temperature of approximately 4,400 degrees Fahrenheit, sufficient to liquefy rock into flowing lava. The entire surface facing the star exists as a global magma ocean, a hemisphere of molten stone churning under intense stellar radiation. Tidal forces lock Kepler-78b, so one side perpetually faces its sun while the other remains in eternal darkness, creating a permanent boundary between molten hell and frozen rock. The planet's existence violates current formation theories, as no known mechanism explains how a rocky world could form so close to its star. Kepler-78b shouldn't exist, yet it does, burning in defiance of our understanding. Moving on, 55 Cancri e, located 40 light-years from Earth orbiting a sun-like star in the constellation Cancer. 55 Cancri e was discovered in 2004 as part of a 5-planet system. This super-Earth measures approximately twice Earth's diameter and 8 times its mass. Surface temperatures fluctuate between 3,200 and 4,900 degrees Fahrenheit depending on planetary orientation. The most extraordinary hypothesis suggests 55 Cancri may be carbon-rich rather than silicon-rich like Earth, with immense pressure and temperature potentially creating a planet where a significant portion of mass exists as diamond. Beneath a surface of graphite and possible silicate, layers of compressed carbon could form diamond structures hundreds of miles thick. However, recent observations indicate extreme temperature variations and possible volcanic activity, suggesting a hellish surface of flowing lava rather than pristine crystalline beauty. Whether diamond world or lava planet, 55 Cancri e demonstrates that cosmic treasures come with conditions incompatible with human survival. Up next, TRES-2b, discovered in 2006 approximately 750 light-years distant in the constellation Draco. TRES-2b holds the distinction of being the darkest exoplanet ever measured. This Jupiter-sized gas giant reflects less than 1% of the light that strikes it, making it darker than coal or black acrylic paint. Orbital proximity to its parent star creates surface temperatures exceeding 1,800 degrees Fahrenheit, yet the planet absorbs nearly all incident radiation. The extreme darkness likely results from atmospheric chemicals like vaporized sodium, potassium, and titanium oxide that absorb light rather than reflecting it, combined with the absence of reflective clouds. Despite absorbing almost all light, TRES-2b emits a faint red glow from its own heat, like a burning ember in the cosmic void. Astronomers describe it as darker than anything in our solar system. TRES-2b is a world that swallows light itself, a sphere of absence hanging in space, visible only by the star it obscures. Next, we have HAT P7b, positioned approximately 1,040 light-years from Earth in the constellation Cygnus. HAT-P7b was discovered in 2008 as a gas giant larger than Jupiter, orbiting extremely close to its host star. Orbital period measures just 2.2 Earth days, with temperatures reaching 4,700 degrees Fahrenheit. The planet experiences aluminum oxide condensation in its upper atmosphere, clouds made of corundum, the crystalline mineral that forms rubies and sapphires when containing trace elements. These exotic clouds produce precipitation of aluminum oxide crystals, essentially gemstone rain. Wind patterns blow these clouds around the planet at tremendous speeds, creating shifting patterns of atmospheric aluminum oxide. The extreme temperatures and intense stellar radiation create turbulent weather systems unlike anything in our solar system. HAT-P7b demonstrates that even gems become instruments of destruction when forged in conditions hostile enough. Next up, CoRoT-7b. Discovered in 2009, approximately 490 light-years distant in the constellation Monoceros, CoRoT-7b was one of the first confirmed rocky exoplanets. This super-Earth measures 1.7 times Earth's diameter and 5 times its mass. Orbital distance of 1.6 million miles from its parent star results in a scorching dayside temperature of 4,000 degrees Fahrenheit, while the tidally locked nightside plunges to minus 350 degrees. The intense stellar heating vaporizes surface rock, creating an atmosphere of vaporized stone. As this silicate vapor rises and cools, it condenses and falls as pebble rain, precipitation consisting of solid rock stones rather than water droplets. The surface likely features lava lakes and rock vapor geysers, erupting from a landscape of perpetual geological violence. CoRoT-7b shows a world where the rock cycle operates at atmospheric speeds, where mountains evaporate and precipitate like earthly water. Moving on, Gliese 1214b. Located 48 light-years away in the constellation Ophiuchus, Gliese 1214b was discovered in 2009 as a super-Earth approximately 2.6 times Earth's diameter. Mass measurements indicate density too low for pure rock but too high for pure gas, suggesting composition dominated by water. However, orbital proximity creates surface temperatures around 450 degrees Fahrenheit and pressures that transform water into exotic states. The planet likely features a water layer hundreds of miles deep, but not liquid water as we know it. Immense pressure creates superionic ice, a bizarre state where oxygen atoms form crystalline lattice, while hydrogen atoms flow freely through that structure like liquid, conducting electricity like metal. Deeper still, pressure may create Ice 7 and Ice 10, crystalline forms that remain solid at temperatures exceeding 1,000 degrees. Gliese 1214b demonstrates that even familiar substances become alien under extreme conditions, a water world where water behaves like nothing on Earth. Up next, PSRB 162026b. Situated 12,400 light-years distant in the globular cluster Messier 4, PSRB 162026b was discovered in 2003, orbiting a binary system consisting of a pulsar and white dwarf. At approximately 12.7 billion years old, this planet formed roughly 1 billion years after the Big Bang itself, making it the oldest known planet in the universe. With 2.5 times Jupiter's mass, this ancient world orbits its stellar remnants in a chaotic three-body system where gravitational interactions create orbital instabilities. The planet survived its star's violent deaths, enduring the red giant phase and supernova explosion that created the pulsar. It now orbits stellar corpses in a radiation-saturated environment, bathed in the intense electromagnetic emissions from the pulsar's rotating magnetic field. PSR B162026b witnessed the universe's youth and has outlived entire stellar generations. This is a planet that survived apocalypse, a world haunted by ghosts of dead stars. Finally, Kelt 9b, discovered in 2017, approximately 670 light-years distant in the constellation Cygnus. Kelt 9b orbits the hottest star known to host planets. This ultra-hot Jupiter completes one orbit every 1.5 Earth days, resulting in dayside temperatures reaching 7,800 degrees Fahrenheit, hotter than many small stars and exceeding the surface temperature of approximately 80% of stars in our galaxy. At these temperatures, molecules cannot exist. Hydrogen molecules split into individual atoms, and atmospheric metals vaporize and ionize. The planet is literally evaporating, losing mass through atmospheric escape at an estimated rate sufficient to create a comet-like tail of planetary material. Ultraviolet radiation from the parent star bombards Kelt 9b with such intensity that the planet glows like molten metal. The night side, while cooler at around 5,400 degrees, remains hot enough to vaporize iron. Kelt 9b represents the ultimate extreme, a planet being incinerated in real time, where the distinction between star and planet blurs into radiating plasma hell.